Welcome to my channel. I'm Zhang Xu. Let's look at the problem 78 in chapter 10. Chapter 10 is about the rotational motion. First one, we consider the example 10 over 20, right? For this one, we need to find how far has the ball moved down to the land when it starts to rolling without slipping. So the example tells us to find the time, how long it takes for rolling without slipping. So we can review it at first. This part is the content in example 20. So you don't need to write in your homework. We can review it because we start from there. And the requirement for the rolling without slipping, that means the leader velocity and the angular velocity must satisfy this equation. Agree at the point of time. From this time, it's just rolling without slipping. Now, how can you find the VCM? It's easy. We can consider Newton's second law. We find the net force on the x component is just a fraction. Agree? And this negative fraction equal to mass times acceleration. And the fraction is mu k mg. In this case, you get the linear acceleration, negative mu k g, and then the velocity for the leader velocity is v0 plus at. So then you input it inside, it is there. Now we get the velocity for cm linear. Now we need to find the angular velocity for omega. At this point of time, what it is? We need to consider the angular acceleration, right? So because this omega is initially is stationary, so 0 plus alpha times t. This alpha, can you find it? Yes. We can consider Newton's second law on the rotational motion. The net torque equal to I alpha, right? And this I is the momentum of inertia for this ball. And the alpha is this one. You inputted it inside, and the omega, and the fraction is mu k mg. So now you can get the function look like this one. See? In this function, you can get the alpha angular acceleration is 5 mu kg divided by 2r. Input it inside, you get the omega cm at this point of time is this one. Now you can say you have this function, right? Linear velocity equal to angular velocity times r. So now you input this one there, omega there. You get a function look like this one. Then you solve the time. You get how much time take for the ball from stationary to start rolling without slipping from initial, right? Now we need to find how far it moved. How far it moved is just the leader motion from initial to the final position. So we consider the leader distance. The distance is v0 t plus 1/2 at squared. There, the a is get negative mu kg, and the t is get from the previous one, so you get the final answer. The next one asks you find the final linear and rotational speed. So linear and rotational speed, how easy it is, right? Because there we get these two functions. Linear velocity function with time t and angular velocity function with t. So you just input this function. Then you input it inside, you get it. And the v is v0 plus at. Now you get the final answer there. Omega is this one. So v over r, you get the final answer there. Thank you.